Okay, so we are recording right now. So domain and range. Okay, guys? Jordan De La Cruz, I feel like you're just asking a question so I could say your name so everybody could hear me online. What?
The graphs and the equations.
What?
You know how you have all the parabolas on
Uh-huh.
the equations? We have to write all that.
It's up to you. It's up to you. Okay, all right, so the domain. Now, number one about the domain. If you guys had to take a guess, and it really shouldn't be a guess because last year in Math 1, I know if you went to Clovis High School, domain and range was covered. And we actually even covered it a little bit yesterday in class. Is domain associated with the x or the y axis? If you had to take a guess, what would you guess? You guys are very good guessers, but it's probably not a guess. Okay? So domain is associated with the x axis. Okay? And the second thing about domain is it's a comparison of how far a graph extends to the left and the right. That's what domain is. So there are 2 points that when you see the word domain, you should associate those 2 things, those 2 points with it. You don't have to have those memorized word for word, but this is what you should associate it. I say the word domain, immediately in your brain, something should click off in your brain that you're thinking, oh, he's talking about the x-axis, and it's a comparison of how far the graph extends to the left and to the right. Okay? The range, on the other hand, is kind of the opposite of the domain. So instead of being associated with the x-axis, the range is associated with the y-axis. Okay? So the range is associated with the y-axis. Fun fact, by the way. Joke of the day. I can only remember 25 letters in the alphabet. I don't know why.
Oh, wow.
Joke of the day. Number 2. That was joke of the day. Hey, and by the way, fun fact. Next year when you're in Math 3, you're going to learn that there's actually a z-axis on a graph. Yeah. So you've got x, you've got y, and then actually the z-axis is an imaginary axis that extends straight up out of the paper and straight down below the paper. So the purpose of a z-axis is it allows you to graph things in 3-dimensional form. No, it's z, not y. Yeah. Because life exists in 3 dimensions, not 2 dimensions, right? Okay, and the range is a comparison of how far a graph extends down and up. Okay? So the range it's associated with the y-axis, and it's a comparison of how far a graph extends down and up. In that order, by the way. Okay? And I wrote it specifically, you guys, for domain when I said it extends to the left and the right. I wrote that in order. I wrote that in a specific order, left and then right. For range, I wrote this in a very specific order. It's always a comparison of how far a graph goes down and then up, okay? So the order that I wrote it is very important. So let's look at the first graph right here. You notice we have 4 graphs. Each graph is what kind of graph? Say the word.
Parabola.
Parabola. Each one of these graphs is a parabola, okay? And all we're going to do is we are going to talk about what is the domain of each graph. And we're going to talk about how do you write that. And we're going to talk about what is the range of this graph. Okay? And I'm going to give you 2 ways to write the domain. And I'm going to give you 2 ways to write the range. Okay? And you need to recognize both ways on how to do it. So let's talk about the domain. Remember, the domain is a comparison of how far a graph extends to the left and to the right. So if I'm looking at this parabola right here, and you guys, would you guys agree or disagree with this statement? Does this parabola, this one right here,
Yes.
does it keep extending, getting wider as we look at it going to the left?
No. Yes.
Okay? Does like the parabola just keep getting wider and wider and wider?
Yes. Yes.
Yeah. So if it, and do you think it will never stop getting wider, or do you think it'll eventually like straighten out?
No, it's infinite.
No, so it keeps getting wider. So you guys, first thing about parabolas are, parabolas continuously get wider. They never stop and narrow out at a certain value that they start just going straight up and down. So to the left, so if it keeps getting wider to the left, what number do we associate in math with something that just keeps going forever and ever and ever?
Infinity.
Right, infinity. Okay? And if it keeps going to the left, would that be associated with a positive or a negative infinity? Negative infinity. So the domain extends to the left to negative infinity. To, how about to the right?
Infinity.
It keeps going to positive infinity. Okay? So if we said the domain is negative infinity to positive infinity, what you're mathematically saying is that how far does the graph go to the left?
Forever.
Forever. It keeps getting extending to the left. It keeps getting wider and wider and wider. How wide does the graph get to the right?
Thick. Like,
What's
forever and ever.
it's saying forever. That's what we're saying. So when we say the domain is negative infinity to positive infinity, we're saying this graph just keeps getting wider in both directions, left and right. Okay? Now, guys, negative infinity. If I say, I am thinking of a number, it's somewhere between negative infinity to positive infinity.
Yeah.
What could the number that I'm thinking of possibly be?
Any number.
It could be any number there is. So another way to write the domain, other than this, is you could literally say the domain is all real numbers.
Is there a fake number?
There is a fake number, and you're going to learn about it in about 2 weeks. But it's not called a fake number. It's actually called an imaginary number. That's what we call a tease in the radio business right there. You know? But, you guys, so if you say the domain is negative infinity to positive infinity, I will accept that as a correct answer. If you say the domain is all real numbers, I will accept that as a correct answer as well. Do you have to write both answers? What's the... No. You write one or the other. Okay? All right, now let's go to the range. Now the range is a comparison of how far a graph extends down and up. Okay? So let's look at this parabola. Range. First of all, we look at how far it extends down. Does this graph go down forever?
No.
No. Does it bottom out at some point?
Yes.
It actually bottoms out right there. And by the way, what is the official technical name for the point, the very lowest point on a parabola?
The minimum.
That is called the minimum, and it's also called the vertex. So that is the vertex, and it's a minimum. So this graph does not go down forever. It stops at a certain value. Okay? And then for range, what do we associate? The y or the x-axis? The y-axis. What number on the y-axis does this graph stop going down at?
Is that -4?
Great question.
-6.
Is it -4? Right there?
Yeah.
Yeah. So the range goes down to -4. 2, and then it's a comparison of how far does the graph go up.
Infinity.
Does this graph stop going up at some value?
No.
Or does it keep going up forever?
No, forever.
You guys, does it keep going up forever?
Forever.
Yeah, by the way, what's the clue to you in the picture of the graph that it keeps going up forever? The arrows. So what number do we associate if it keeps going up forever?
The sideways.
Positive infinity. So we would say the range is -4 to infinity. Okay? What does this mean? It means that the graph goes down to what number? -4, but it goes up to forever. To infinity. Okay? Now, guys, I'm going to write something next, and what I'm going to write next is another way to write this. And this other way that I'm about to write, -4 to infinity, you're not going to like.
Okay.
But I'm still going to write it. I'm going to write this as what we call a compound inequality. Okay, so watch. I'm going to put a y. Why did I put a letter y? Because range is associated with the y-axis. And then I'm going to put a less than or equal to sign, and then I'm going to put infinity. And then on the other side of the y, to the left of the y, I'm going to put a greater than or equal to a sign, and then I'm going to put -4.
Do we have to do that?
You do not have to do that. But you have to recognize what this means. This right here is another way to say that the range is from -4 to infinity. Okay, this is the fancy mathematical way on how to write it. All right, so if you were in college and your professor was talking about this, your professor would never write -4 to infinity. Your professor would write that second way to represent it. But this is, both of these ways are ways to represent -4 to infinity. Okay? We all good so far? Yeah? Okay, the next 3 should go pretty quick, because I'm not going to go into like deep explanation. So moving on to the next parabola, which is this one right here. And you guys, would you guys say this is an upwards or a downwards parabola?
Downward.
Okay, good. You got to understand the terminology. Okay, so what's the domain of this parabola? Negative infinity to positive infinity. All right, now what are we saying when we say that? Right, so we're saying it's all real numbers. So that's every single number that exists under the number line scope of math. Okay, but when we say the domain is negative infinity to positive infinity, we're saying how far does this graph go to the left? How wide does this graph go to the left?
Infinity.
Forever. That's negative infinity. When we say positive infinity, we're saying how wide does this graph go to the right? Forever. So we're saying this graph just keeps getting wider and wider and wider in both directions. That's what we're saying when we write the domain like this.
Yeah.
Okay, now let's go to the range. Okay, so the range, remember, it's a comparison of how far the graph extends down. It's always down first and then up second. So, how far does this graph extend down?
Negative.
No, down.
Yeah. Infinity.
Does the graph keep going down forever?
Yes.
That'd be negative infinity.
Oh.
So the range is negative infinity
Yeah.
2, and then does this graph keep going up forever?
No.
No. It has a maximum point.
Yep.
Right there, and what point is that associated with on the y-axis?
-1.
So we would say, you're correct, in -1, so the range is -infinity to -1. Now, watch how I'm going to write that the fancy mathematical college way. I'm going to put the letter y. Instead of the word 2, I'm going to put the letter y. And then I'm going to put this less than or equal inequality symbol. And then I'm going to put a -1. Then I'm going to go to the left of the letter y, and I'm going to put that same inequality symbol that I put over here, and then I'm going to write -infinity. You guys, that right there is the fancy mathematical way for saying that the range is going to be somewhere between -infinity and -1. Okay? You have to recognize that. You'll have a couple multiple choice questions on an upcoming test where it'll express the range like this, so you have to know how to read it. Okay? All right, moving on to the next one. Here we have another, downwards parabola. Okay? So the domain. What's the domain? Negative infinity to positive infinity. How could you write that another way? What's another way to write? All real numbers. So that means all real numbers. Oh, by the way, do you guys want to know the mathematical symbol for the phrase all real numbers?
Bless your soul.
Hey,
Say it again.
I'll ask again because nobody answered. That was really awkward when I ask a question and nobody answers. Do you want to know the mathematical symbol for the phrase all real numbers?
Yes, please let me know.
You put a capital R
Uh-huh.
and then put another line like that.
In real life.
That is the mathematical symbol for the phrase all real numbers. So for the domain, if you're an educated human being, which is all of us, if you see that symbol for the domain, an educated human being knows, what does that mean? All real numbers. Which means negative infinity to positive infinity.
Yes.
Okay? All right, then we get to the range. Yeah, it looks like an IR, but it's not. It's like a double-lined R. All right, so the range is, you guys, once again, the range is a comparison of how far the graph goes down. How far does this graph go down? Forever, so that'd be negative infinity. To, how high does it go? Right, -4. You can see that's the highest this parabola gets, and that's associated with -4 on the y-axis. So the range would be negative infinity to -4. Okay? You guys, if you wrote the -4 first and the negative infinity second, would that be considered incorrect?
Yes.
Yeah. It has to be because you're saying it goes down forever and it goes up no higher than -4 on the y-axis. Now I need to write that the college way. So I put the letter y. I put the inequality less than or equal to. I write -4. Then I go to the left of the y and I put that same inequality symbol, the same exact one, facing the same direction, and then I put a negative infinity there. Okay? So we have that. Okay, guys? All right. Oh, by the way,
Right there you do -4 to infinity, and then that one you do -infinity to, because that one goes down.
that one, because that's how far it went down. This one is how high it went up. So that's why the -4 is in different spots. That's a great question, though. Okay, hey, by the way, somebody make a hypothesis, that means an educated guess, about what the domain is for every single parabola.
Negative infinity and positive infinity.
So, you guys, if you ever get a domain question wrong about a parabola, you just flat out haven't been paying attention. Okay, so we go to the last one. What's the domain of this wider downwards parabola? negative infinity to positive infinity, which we could express as all real numbers, which you could simply just express as the mathematical symbol, which is a capital R with an extra line there. It looks like IR, but it's not. Okay? Any one of those three answers is an acceptable answer for the domain. Okay? Then we go to the range. Okay, the range. How far does this parabola go down? To negative infinity. It goes forever down. 2, does this parabola keep going up forever?
No.
No. Does it maximize at its up?
Yes.
Yeah, right here. And what number is that associated with on the y-axis?
-4.
So the range would be negative infinity to -4. Okay, and once again, the way that you could express that in the collegiate level way would be you would put the variable y, then you would put a less than or equal to symbol and a -4. Then to the left of the variable y, you would put that same exact symbol and put a negative infinity. That's called the compound inequality there. Okay?
Thank you.
So you guys, are we good so far?
Yes.
All right. Okay, so domain and range. Moving on. We got one more thing to cover.
Oh.
This part is part 2. Okay, you guys? Part 2 is a point, once I get my pin working, there we go, is a point a solution for a given equation. This is the second thing that you're responsible for today, knowing how to mathematically figure out. All right, and since you guys are hands down my smartest class of the day, no offense to first, third, fourth, or seventh period,
Yeah.
but second period is incredibly intelligent.
That's why I transferred.
Yeah, that's why Kenny and Jordan transferred into second period, because they actually had to bring down the average score of second period to make it closer to the other classes.
That's so sad.
And by the way, I'm not going to say which one's my worst class, first or third or fourth or seventh, but hello, seventh period, if you're watching this.
7th period.
Seventh period is, let's just say the elevator's not going all the way to the top, you know, if you know what I'm saying. I'm totally kidding. Seventh period's awesome. They're my best class after lunch that I have every day.
Your only
First period.
You're right, Nia. They are my only class after lunch, but they're my best. Okay? Okay, so here we go. Here's an equation. I'm going to give you an equation. It's going to look scary. Maybe. Y equals 3x squared plus 4x plus 2. Somebody like super awesome, which is all of you, tell me what's the name of that kind of equation.
Quadratic.
It's a trinomial and it's a quadratic. I like it. So if I were to graph this, and I'm not going to graph it, but if I were to graph it, what would the graph look like?
It would
It'd be a parabola. Would it be going up or would it be going down? It'd be going up. You guys are catching on to this stuff. Okay, and then I'm going to give you a point. Here's the point. 0, 2. So here's what I'm asking in this problem. I'm asking you, is that point that has the coordinates 0, 2, is it a solution to this particular equation?
Yes.
Okay, now, obviously you could immediately say yes or you could immediately say no, and you have a 50-50 chance of getting it right. Okay, but here's what I'm technically asking you. I'm technically asking you that if you were to graph this equation and get a parabola, would that point actually be on the parabola? Like, would that dot, that point,
Yes.
actually be on that parabola? That's what I'm asking.
Yes.
Okay? And I'm going to show you how to do it without having to graph it at all. Because would you guys all agree that graphing's kind of not a super hard process, but is it a kind of a lengthy process? Yeah. Okay. Watch how we do this. This point is called an ordered pair, which means 0 is the x value, 2 is the y value. That's how an ordered pair works. So what I'm going to do is I'm going to go to my equation, and every time I see the variable y, I'm going to substitute what number in its place? A 2. And every time I see the variable x, what number am I going to substitute in its place? A 0. And then I'm going to do some simple math, and I'm going to see what happens.
Yes.
Okay, so watch. Here we go. So I'm going to rewrite this equation. But I'm not going to have y's or x's. I'm going to have nothing but numbers. So what should I put here?
2.
A 2. Equals. Should I still have the 3?
Yes.
Yes. Should I still have the x?
No.
What do I put?
0.
And put it in, you're right, put a 0, put it in parentheses. Should I still have the exponent of 2?
Yes.
Yeah. Should I still have a plus and a 4?
Yes.
But I shouldn't have an x, I should have a...
0.
Yeah, you guys are awesome. And should I still have a plus and a 2?
Yes.
Okay. Now I'm going to work this out. First of all, the left side of the equal sign you can't work out. It's 2. There's nothing you can do with that. So when I work out the left side of the equal sign, it's a 2. But can I do some math, and can I definitely simplify the right side of the equal sign?
Yes.
So what is 3 times 0 to the second power plus 4 times 0 plus 2?
2.
That is 2. 2 equals 2. Did this work out? So what do you think? Do you think that point is actually a solution for this equation?
Yes.
So do you think that point would actually be on the graph of that equation?
Yes.
All right, so here's what we just found out. This checked out. So what does that mean? It means 0, 2 is a solution for y equals 3x squared plus 4x plus 2. Okay? That's what we just found out. All right? You get the concept of it?
Yeah.
All right, let's do one more, and then we'll be done. Number 2. Do you want me to make up a new equation, or do you just want to use the same equation as number 1? All right, let's use the same equation. So number 2, here's my equation that we're going to use. I like it. Thank you for saying same equation. I don't even have to think of a new one. So I have y equals 3x squared plus 4x plus 5. See, that's why you guys are my smartest class. I did this in first period, and 7 minutes later somebody goes, wait a second, that's not the same equation as number 1. I literally timed it. It took them 7 minutes to figure it out. Great job, first period.
What was Isaiah?
Point.
We're second period.
I know, but first period, it took them 7 minutes to figure it out.
It took us 7 seconds.
It was the birthday boy, James, to figure it out. Okay, yeah. James Q, whatever his last name is. There. Okay, so here's the point. 2, comma, 27. That's the point. 227. I just made that up. And by the way, can anybody see, somebody give me a valid reason why you would not want to graph this.
Because
27 is y.
Yeah.
It doesn't work.
You would need a big piece of graph paper to graph the point over 2 up 27. Okay? But can we figure out if this is a solution without even graphing? Yeah. Once again,
It's not.
x is 2, y is 27. I'm going to substitute those values into my equation. So instead of y, what am I going to write? Come on, hey, I feel like I lost half of you. Yeah, 27, good job. Equals 3. Instead of x, what do I write? 2. And you guys, when you substitute a number in the place of a variable, always put that number in parentheses, please.
Yeah.
Plus 4, instead of x, once again, I substituted 2, plus 5. Okay? And then I work this out.
Doesn't work.
Okay, now the left side of the equal sign cannot be worked out. It's 27. I'm stuck at 27 there. However, the right side of the equal sign, you guys are going to help me out. Okay, you ready?
Yeah.
What is 2 to the second power?
4.
Times 3.
12.
So this first part becomes 12. Plus 2 times 4 is
8.
8. Plus 5. What's 12 plus 8 plus 5?
25.
So I get 27 is equal to 25. That does not work. Those aren't equal. Okay, like if my buddy had 27 jelly beans and he's all, hey Trutna, I'm going to give you the same amount as I have, and he gives me 25, I got an issue with him.
You should fight him.
Yeah, I would fight him. It'd be a 2-hit fight. Me hitting him hitting the ground. Fury versus Wilder. 27. So what does this tell me?
It doesn't work.
Is 227 a solution?
No.
No. So we know that the point 227 is not a solution. Okay? For y equals 3x squared plus 4x plus 5.